welcome to Physics in Pro Wrestling. Over the past minute and a half, we've watched many examples of physics in the sport of pro wrestling. Some of the examples which we watched were centripetal force, projectile motion, torque, various collisions, kinetic energy, and as you watched when I was on the top rope, I actually had gravitational potential energy. Now we can focus on many areas in this presentation, but in my opinion, it's important for us to focus on one and express this one area of physics with an experiment. For this example, we're going to use Fulmar. Now, Fulmar and myself basically have wrestled on many different occasions over the years in states which ranged from Virginia, West Virginia, Pennsylvania, New Jersey, to Ohio, so he's an opponent that I know very well. Also, because I know this opponent very well, and I know the rings, basically the wrestling rings that we're in, I know the dimensions of each of the rings that we were wrestling in, and basically I know the different areas of the mat of where basically if we conducted a move, I know the distances between the beginning of the move and the end of the moves, and I also know his weight and my weight. So using Fulmar as an example for this experiment, I believe was one of the best I could find. Now, we're going to view 5 examples of the Fumosity, which basically is a leg drop off the top rope. Now, Fulmar is going to climb up to the top rope, and when he climbs up to the top rope, he's going to collect potential gravitational energy. And when he jumps off the top rope, his initial jump in the x direction is going to be basically the kinetic energy in the x direction, and combined with the potential energy, gravitational energy, and that's the total energy of when he begins the move. And right before he lands, basically he's going to have the lowest amount of potential energy and the highest amount of kinetic energy. So to step back a little bit, when he jumps off the top rope, he's going to have his highest level of potential energy. When he's just about to hit the mat, he's going to have the lowest level of potential energy. But when he jumps off the top rope, he's going to have the lowest level of kinetic energy. And right before he hits the mat, he's going to have the highest level of kinetic energy. Now, the initial total energy of when he jumps off the top rope will equal the final total energy right before he hits the mat. So basically, his energy will be conserved through this process. And over the next 5 trials, which we're going to view, we're going to prove this in our experiment. So let's watch. The principle of conservation of energy states that the total energy of an isolated conservative system remains constant. Therefore, the following hypothesis was created for Fulmar as he executes his leg drop off the top rope. The total energy of Fulmar will be transferred between potential and kinetic forms in each trial, but the total energy will remain constant. Five trials were analyzed of Fulmar's leg drop finishing move. Initial total energy and final total energy were calculated on a spreadsheet and used in a formal laboratory report. Each trial will be displayed, followed by the comparison of total initial energy and total final energy. So basically, we're going to watch 5 videos. A percentage of error equal to 0% displays a system in which all of the energy was conserved. A trial which obtains a low percentage of error is one which is very close to displaying the conservation of energy. After all the trials are displayed, a summary of the trials will be displayed. Now that we've watched trial 1, let's look at the results. Now for the initial total energy, there was 2,954.44 joules. For the final total energy, there was 2,881.51 joules. Now, this was a 72.93 joule loss. And looking at the percentage of error, this was a 2.47% error. Now let's look at the results after watching trial 2. The total initial energy is 3,242.87 joules. The total final energy is 3,229.57 joules. Now at a 13.30 joules loss, this is only a 0.41% error. And in my opinion, this is a very good example of the conservation of energy. Now that we've completed watching trial 3, let's look at the results on basically this trial. So the total initial energy was 2,318.49 joules. The total final energy was 2,286.99 joules. This basically was a 31.51 joules loss, and at 1.36% error. It's another good example of the conservation of energy. Now that we completed watching trial 4, let's look at the results. Now the total initial energy was 2,270.35 joules. The total final energy was 2,184.15 joules. Now this loss was 86.20 joules, which was a 3.8% error. Now this was larger than maybe some of the other trials, but still displays the conservation of energy.
He's got those boots shined up. That shows what it's about.
Now in our last example of trial 5, the initial total energy was 2,380.20 joules, and the final total energy was 2,348.69 joules. Now this was a loss of 31.51 joules, which was a 1.32% error, and again is a very good example of the conservation of energy. Now that we've viewed trials 1 through 5 and their results, let's look at the summary of these results. Now for the percentage of error, trial 1 received a 2.47% error. Trial 2, 0.41%. Trial 3, 1.36%. Trial 4, 3.80%. And trial 5, a 1.32%. Taking these percentages of error and averaging them out, we see that there's an average percent energy loss in the system for trials 1 through 5 of 1.8%. The standard deviation for trials 1 through 5 was 27.66. Now, this calculation was obtained while creating the formal lab report of this experiment. As Fumar traveled from top rope to the mat, his potential energy was reduced, while his kinetic energy increased. The total final energy was very close to the total initial energy. Now, this percentage of error actually wasn't a situation where the energy was destroyed, but it was actually lost from the system due to air resistance. So because understanding that the conservation of energy, that energy cannot be created or destroyed in the closed system. Now, the results basically support the hypothesis the total energy of Fumar was transferred between potential and kinetic forms in each trial, and the total energy remained constant. Going back, I just wanted to say that it is believed that the friction of air, which is air friction, is the cause of the percentage of error for each of the trials. Thank you very much for watching our presentation, and I hope you enjoyed it.
Balsamo sending through. Refereeing there by Tom. And Tom once again getting caught in the opposing corner. Balsamo with that very large double axe.